Hello everyone, and welcome to Earth Archives. Have you ever wondered why sometimes wireless signals suddenly drop, phones can't connect to the internet, or certain areas experience massive power outages? Believe it or not, the sun might be behind it all.
That's right. It's the impact of solar storms. It's like the sun is throwing a giant energy punch at us. Normally, we can't see it, but when it hits, it can really catch Earth's technology systems off guard. A solar storm, simply put, is a powerful eruption from the sun, accompanied by a huge amount of charged particles and intense electromagnetic waves, like a raging storm in space. When this energy reaches Earth, it triggers a series of amazing but potentially dangerous effects. Its power is so strong that it can light up the night sky with beautiful auroras, but it can also disrupt satellite communications, GPS navigation systems, and even affect our power grids. You can imagine that when the sun sends out this strong energy punch, Earth's magnetic field acts like a shield trying to block it. But sometimes it's overwhelmed, causing impacts like a thunderous blow. Once the magnetic field is disturbed, mobile signals suddenly disappear, airplane navigation systems malfunction, and even high-voltage power lines can be damaged, affecting the lives and work of thousands or millions of people. Historically, there have been several powerful solar storm events that caught scientists and engineers by surprise. For example, the Carrington Event in 1859, considered the strongest solar storm on record, caused telegraph systems to fail due to intense electromagnetic pulses and even spark fires. In today's highly technological society, a similar event could have even more far-reaching effects, potentially impacting the global economy and daily life.
Wow, so our lives are actually hugely affected by the sun. Today, shall we talk about the sun's bad temper?
Let's start with the most famous solar storm, the Carrington Event. In 1859, the sun erupted with an extremely powerful storm, bringing about an unprecedented geomagnetic storm. At that time, a strong solar wind carrying a massive amount of charged particles slammed into Earth's magnetic field, causing telegraph systems worldwide to completely fail and even sparking fires. That night, the auroras lit up the sky like daylight, visible all the way from the North Pole to the equator, a breathtaking natural spectacle. The Carrington Event became the most intense solar storm ever recorded and made humanity deeply realize just how strongly the sun's energy can impact Earth. As time went on, we've faced multiple modern solar storm challenges. Though these events were not as powerful as the Carrington Event, they were still strong enough to disrupt our high-tech society. Satellite communications interrupted, GPS navigation errors, power system shorts, and even large-scale blackouts were all caused by solar storms. This reminds us that as we become more dependent on technology, the threat from solar storms becomes increasingly serious. To better understand how solar storms form and evolve, the United States launched the Parker Solar Probe, an unprecedented spacecraft that travels closer to the sun than ever before. The Parker probe bravely flies millions of kilometers, passing through the scorching solar atmosphere, collecting first-hand data on solar storms. These precious data allow scientists to unlock the secrets of sunspots and solar storms, deeply analyze how solar activity affects Earth's magnetic field, and improve early warning systems to protect our power grids and satellite communications.
Okay, let me start with the first basic question. What exactly is a solar storm?
Simply put, a solar storm is like a sudden cosmic storm burst from the sun. When the sun's surface erupts with intense energy, it shoots out a massive amount of charged particles at incredible speeds, hundreds to thousands of kilometers per second, like a violent storm blasting into deep space. These high-speed charged particles are like invisible bullets. After traveling hundreds of millions of kilometers through space, when they hit Earth, they cause strong disturbances to our protective magnetic field and atmosphere, triggering what's called a geomagnetic storm. Earth is surrounded by a magnetic field that acts like a shield, protecting us from solar storms. However, when the energy of these charged particles is too strong, the magnetic field gets severely disturbed and starts to shake violently. This dramatic change in the magnetic field can trigger amazing auroras in high-latitude regions, lighting up the night sky with beautiful colors, but it also carries hidden dangers. The geomagnetic storm causes powerful electromagnetic waves and charged particle flows that interfere with satellite communications and navigation systems on Earth. It can even disrupt power grids on the ground. High-voltage transmission lines and substations may malfunction under intense geomagnetic storms, potentially causing large-scale blackouts. For modern society, these effects are no small matter, since so many systems depend on stable electronics and electricity.
Wow, so the sun is actually like a hot-tempered neighbor who sometimes throws stones at us?
Haha, that's a really fitting way to put it. On normal days, the solar wind is like a gentle breeze, softly and steadily brushing by, giving Earth's magnetic field a little soothing touch. But when solar flares erupt on the sun's surface, or when there's a violent coronal mass ejection (CME), that normally mild solar wind instantly transforms into a massive cosmic typhoon, violently sweeping across the entire solar system, especially targeting our home, Earth. Solar flares are sudden explosions that release huge amounts of energy, like flames bursting out from the sun's surface. They emit intense X-rays and ultraviolet rays, accompanied by a fierce blast of charged particles. Meanwhile, CMEs are huge clouds of solar plasma and magnetic fields, violently hurled out like a flood due to twisted magnetic forces. Together, these two phenomena form the core power behind a solar storm. When such a solar storm reaches Earth, it hits the planet's magnetic field like a powerful cosmic typhoon, stirring up intense geomagnetic storms. Earth's magnetic field acts like a protective shield, trying to fend off this powerful energy blast, but it's often unable to completely defend. As a magnetic field gets disturbed, the night sky lights up with beautiful auroras, glowing ribbons of light created when charged particles collide with atoms in our atmosphere, painting the sky with dazzling cosmic colors.
I'm really curious, has there ever been a solar storm in history that caused serious damage?
Absolutely. When it comes to solar storms, the most famous one is the Carrington Event in 1859, which I mentioned earlier. That year, British astronomer Richard Carrington was carefully observing the sun when he suddenly witnessed an astonishing sight. A super bright flash erupted on the sun's surface. It was a massive solar flare explosion. Not only was the flare dazzlingly bright, but it also signaled the release of an enormous amount of energy. A few days later, this intense solar storm swept rapidly toward Earth like a violent flood. The sun hurled high-speed charge particles that slammed into Earth's magnetic field, triggering an unprecedented geomagnetic storm. The storm was so powerful that it disrupted telegraph systems worldwide. Many telegraph machines suddenly malfunctioned, sparks flew, and even fires broke out, causing communications to grind to a halt. Beyond the collapse of technology, the Carrington Event also gave humanity a rare spectacle, a magnificent aurora display. The auroras weren't just visible near the Arctic Circle. They lit up the skies at much lower southern latitudes with dazzling red, green, and purple lights, so bright it looked like daytime, transforming the night sky into a dreamlike wonderland. This breathtaking scene stands as the best testament to the immense power of a solar storm. To this day, the Carrington Event remains the strongest solar storm ever recorded. It revealed just how deeply solar activity can impact Earth. In today's world, where we rely heavily on satellite communications, power grids, and GPS, a similar event could cause widespread disaster and economic losses on an even larger scale.
So, what was the outcome?
The Carrington Event of 1859 was not only an astronomical spectacle, but also a massive shock to the technology of the time. When the intense solar storm hit Earth, telegraph systems around the world nearly shut down completely. telegraph wires, which relied on electrical currents to transmit messages, were overloaded and burned out, and telegraph machines even sparked, as if they were about to catch fire. It said that some telegraph operators were even shocked by sudden surges of electricity, experiencing severe pain, showing just how powerful that geomagnetic storm was. The storm's impact went far beyond just the collapse of technology. Remarkably, the auroras were no longer confined to high-latitude regions, but unusually spread to tropical areas as well. The night skies over the Caribbean coast, Mexico, and other low-latitude regions were lit up by dazzling auroras. The sky was as bright as daytime, with red and green bands dancing across the heavens, stunning people worldwide. This widespread aurora phenomenon highlighted the immense energy released by the solar storm, far beyond what people had ever imagined nature could unleash. The Carrington Event remains the strongest recorded solar storm in history, making people deeply aware of the potential threats solar activity poses to Earth's technology and daily life. Although telegraph technology was simple compared to today's standards, the destruction it suffered was astonishing. This serves as a powerful reminder that in our modern world, highly dependent on electronic devices and power grids, a similar or even stronger solar storm could have unimaginable consequences.
Oh my gosh. This sounds just like an apocalypse movie.
If a solar storm of the same scale as the 1859 Carrington Event were to hit Earth today, the consequences would be unimaginable. Back then, telegraph systems were almost completely paralyzed. Overloaded currents burned out wires, telegraph machines sparked, and even operators were electrocuted. Now, since our lives rely almost entirely on electricity and satellite systems, a solar storm of that magnitude would cause a global technological disaster. First, the worldwide power grid would face enormous risks. A strong solar storm triggers geomagnetic storms that violently shake Earth's magnetic field, inducing massive currents in ground-based power systems. This could damage transformers and high-voltage equipment, potentially causing large-scale blackouts. This wouldn't just affect daily life. Critical infrastructure like healthcare, transportation, and finance would suffer severe disruption. Imagine entire cities plunging into darkness, communications cutting out, logistics grinding to a halt, and global economic activities coming to a standstill. The losses would be incalculable. Furthermore, satellite systems are equally vulnerable. Modern society heavily depends on satellites for communication, navigation, weather monitoring, and military intelligence. High-energy particles from solar storms can interfere with satellite electronics and even destroy key components, causing satellites to fail. GPS positioning would become unreliable, flight and shipping routes would descend into chaos, communication networks would break down, and global internet services could be affected. Experts estimate that if a Carrington-scale solar storm happened today, global economic losses could reach trillions of dollars. This is not just a financial figure. It's a stark warning about the massive impact such an event would have on countless families' and businesses' lives and futures.
Have there been any recent occurrences too? Or was the Carrington Event the only one?
There have been many examples in history where solar storms impacted Earth, far beyond just the Carrington Event. In 1989, Quebec, Canada, experienced a painful lesson. That year, a strong solar storm caused severe disturbances in Earth's magnetic field. These geomagnetic disturbances induced powerful currents in the ground-based power grid, directly causing the collapse of Quebec's electrical system. The blackout happened extremely quickly. Within 9 hours, the entire Quebec region was plunged into darkness, disrupting the lives of about 6 million residents. Street lights went out, traffic signals stopped working, hospitals had to rely on backup power to keep running, and offices and factories were forced to halt operations. This blackout not only caused great inconvenience, but also brought the regional economy to a standstill, with losses that are difficult to estimate. This incident clearly revealed the immense threat solar storms pose to modern infrastructure. The charged particles carried by solar storms, upon entering Earth's magnetic field, cause violent magnetic fluctuations, which induce strong currents in conductors on the ground. These geomagnetically induced currents can damage critical equipment in power systems, especially large transformers. Once damaged, repairs can take months or even years.
That's serious. So, do airplanes and satellites also get affected?
The power of solar storms goes far beyond what we experience daily, and their impact on modern technology is especially huge. When a strong solar storm hits, communication systems in the upper atmosphere are the first to be disrupted. This can cause airplane communications to drop, forcing airlines to urgently reroute flights, especially those crossing polar regions, which face the highest risks. This not only affects flight safety, but also causes delays and increased costs. Even more seriously, solar storms can cause satellite systems to fail. Satellites are indispensable infrastructure in modern society, responsible for GPS navigation, weather forecasting, communication transmissions, TV broadcasting, and more. High-energy charged particles released by solar storms interfere with satellite electronics, causing signal loss or even permanent damage. When GPS positioning becomes inaccurate, mobile signals weaken, or satellite TV broadcasts are interrupted. All these issues may happen simultaneously. Imagine during a global-scale solar storm. Your phone can't connect to the internet. Navigation systems fail. Long-distance communications are cut off. Society's operations would descend into chaos. Both personal lives and business activities would be severely impacted. Especially in emergency response and public safety, communication failures could drastically reduce rescue efficiency and endanger more lives.
Wow! It sounds like solar storms are the cosmic hackers that can crash our systems anytime. Is there any way to predict them?
That's where our solar detective comes in, the Parker Solar Probe. Launched by NASA in 2018, this probe has a special mission: to get as close as possible to the sun and even touch the solar wind, uncovering the deepest secrets of this blazing star. The probe is named after Eugene Parker, an American astrophysicist who first proposed the solar wind theory. The Parker Solar Probe is the first man-made object in history to get this close to the sun. Designing the Parker Solar Probe was extremely challenging. To withstand the sun's extreme heat and intense radiation, the probe is equipped with an advanced heat shield that can endure temperatures over 1,300 degrees Celsius, protecting its delicate instruments. It orbits the sun at incredible speeds, breaking many space exploration records, collecting abundant data that helps scientists understand the origin, structure, and behavior of the solar wind. The first-hand data from the Parker Solar Probe not only reveal how solar storms form, but also show how phenomena like sunspots, solar flares, and coronal mass ejections work. These findings are crucial for predicting solar storms and protecting Earth's power grids and satellite systems. Thanks to the Parker Solar Probe, we are starting to truly understand how the sun influences the entire solar system, and even human life.
Touch the sun. Wouldn't it get burned?
The Parker Solar Probe is a groundbreaking space mission equipped with an ultra-strong heat shield that can withstand extreme temperatures over 1,400 degrees Celsius. This heat shield is the key that allows the probe to approach the sun and dive deep into the corona. While the sun's surface temperature reaches thousands of degrees and the corona is even hotter, which would be fatal for ordinary instruments, Parker successfully resists the sun's intense heat thanks to this advanced thermal protection technology. Besides its incredible heat resistance, the Parker Solar Probe's speed is equally astonishing. It travels at about 690,000 kilometers per hour, making it the fastest spacecraft in human history. This incredible speed enables Parker to quickly pass through the sun's intense radiation zones and rapidly collect a vast amount of precise solar wind data. These data include the solar wind's composition, speed, and magnetic field structure, providing scientists with an unprecedented perspective to unlock the secrets of solar activity. The mission of the Parker Solar Probe is not just to gather data, but also to help humanity predict solar storms and provide early warnings of solar eruptions that might affect Earth's technology systems. In the past, we could only guess the movement of solar storms through distant observations, but now, with Parker's close-up measurements, we can understand the origins and evolution of the solar wind more accurately, improving Earth's protective measures.
So cool. It feels like a cosmic correspondent running right up to the sun to live stream the scene. But I still don't quite get it. What exactly is the connection between solar storms and the aurora?
That's the romantic part. When the charged particles, carried by the solar wind, rush along Earth's magnetic field lines toward the polar high-latitude regions, they put on a dazzling light show. These fast-moving charged particles collide with molecules in Earth's atmosphere, exciting them to emit colorful light, creating the natural wonder we call the aurora. The colors of the aurora are rich and varied. The most common is green, because when charged particles hit oxygen molecules, the oxygen emits a bright green light. Besides green, there are also red and purple hues. Red light comes from oxygen molecules at higher altitudes, while purple and blue lights are emitted when nitrogen molecules are excited by the charged particles. These lights weave and dance across the night sky, like a ballet of colors, adding warmth and mystery to the cold polar nights. The aurora isn't just a feast for the eyes. It's a beautiful display of energy exchange between the sun and Earth. It reminds us that the solar wind isn't just an invisible threat, but a poetic force of nature in the cosmos. Ancient peoples even saw this light as a messenger from the gods, carrying blessings and mysterious powers.
Wow, so the aurora isn't just a beautiful sight, it's like the electromagnetic dance between the sun and Earth?
Exactly right. Although the aurora is stunning and colorful, like ribbons dancing across the night sky that attract countless onlookers, we can't ignore the hidden dangers behind it. The appearance of the aurora often signals the arrival of a solar storm. This powerful energy flow from the sun not only lights up the sky, but also poses serious threats to Earth's technology systems. When a solar storm carries a large number of charged particles rushing along Earth's magnetic field lines into high-latitude regions, the aurora is born. But this force also disturbs Earth's magnetic field, causing what's called a geomagnetic storm, which affects many electronic devices and infrastructures we rely on. The power grid can experience induced currents, causing transformers to overload and burn out, leading to large-scale blackouts. Satellite electronics are also vulnerable to interference. Navigation systems like GPS and communication satellites may fail. Cell phone signals and TV broadcasts can be disrupted, and even airplane communications might be affected, sometimes forcing flights to reroute to avoid dangerous areas.
So, are solar storms related to sunspots?
Sunspots are like energy reservoirs, where the magnetic field on the sun's surface is especially strong. Although these spots appear dark, they actually contain enormous amounts of energy. They are key points of solar activity, much like cosmic powder kegs ready to release their stored power at any moment. When the magnetic fields on the sun's surface suddenly realign, this energy bursts out instantly, creating solar flares and coronal mass ejections, CMEs, which trigger intense solar storms. You could say sunspots are the flashpoints of the sun, and solar storms are its temper tantrums. These eruptions are not only spectacular astronomical phenomena, but also natural forces that have far-reaching impacts on Earth. Solar flares are like fiery sparks from the sun, releasing large amounts of high-energy radiation, while CMEs are powerful cosmic storms that propel charged particles at extremely high speeds into space, heading straight toward our planet. When these charged particles reach Earth, they interact strongly with Earth's magnetic field, causing geomagnetic storms, the source of the auroras we see and the disruptions to our technology systems. The activity cycle of sunspots is closely linked to the frequency of solar storms. By observing the number and changes of sunspots, scientists can predict possible solar storms in advance, helping us prepare and mitigate their effects on Earth.
It sounds like scientists took a long time to figure this out, right?
Behind the mysterious lights of the aurora lies a history full of scientific exploration and courage. Norwegian scientist Christian Birkeland was a pioneer in aurora research. In the early 19th century, he proposed that the formation of the aurora was closely linked to solar activity. At that time, many in the scientific community were skeptical, but Birkeland used experiments and theoretical reasoning to successfully demonstrate that the interaction between charged particles carried by the solar wind and Earth's magnetic field was the key to the aurora's glow. As time went on, another outstanding scientist, Eugene Parker, proposed the solar wind theory in 1958. He suggested that the sun continuously releases high-speed charged particles, creating a constant wind blowing out into space, what we now call the solar wind. Although this theory was initially met with much doubt and even considered far-fetched, Parker persisted in his research, waiting for technological advances to prove his ideas. With the development of space probes, humanity finally gained the chance to observe the solar wind up close. Data from these probes confirmed Parker's theory clearly, revealing the existence and behavior of the solar wind, and completely changing our understanding of the sun and the solar system. To honor this great scientist's contribution, NASA named the fastest and closest to the sun probe in history the Parker Solar Probe, ensuring his name is forever engraved in the history of solar science.
Wow, it sounds like an inspiring story of a kid who was laughed at but grew up to have their name written in history. So how does the solar storm cycle work?
The sun's activity cycle lasts about 11 years. It's a natural rhythm full of ups and downs. The number of sunspots rises and falls with the cycle, sometimes peaking dramatically, other times remaining calm like still water. This cycle not only affects the changes in sunspots on the solar surface, but also directly influences the frequency and intensity of solar storms. When sunspot activity reaches its peak, the sun's magnetic field becomes highly turbulent, and solar flares and coronal mass ejections, CMEs, increase, meaning strong solar storms will strike Earth more frequently. Right now, we're in a phase where solar activity is gradually increasing, and it's expected to reach a new peak around 2025. This means that in the coming years, the occurrence and intensity of solar storms could rise significantly. For Earth's technological systems, this is both a test and a warning. Satellites, power grids, communication systems, and even aviation and aerospace could all face serious challenges from the sun's intense energy.
Wow, so we might witness more spectacular auroras, but at the same time, we have to be cautious about power outages and internet disruptions?
Exactly. As technology rapidly advances, human society's dependence on electricity and communication grows deeper than ever, which makes the threat posed by solar storms unprecedentedly huge. From everyday devices like smartphones and computers to power grids and transportation systems that keep cities running, and even to satellites essential for global navigation and internet communications. All of these technologies rely on stable and continuous power and signal transmission. However, when the high-speed charged particles carried by a solar storm collide with Earth's magnetic field, they can trigger intense geomagnetic storms, causing huge impacts on power systems. Historically, events like the 1859 Carrington Event and the 1989 Quebec blackout caused the communications and power systems at the time to collapse. Today, with technology being far more complex and widespread, a similar or stronger solar storm could cause even more extensive and severe blackouts, potentially delivering fatal blows to financial markets, medical equipment, aerospace, and national defense systems. Satellites in space, responsible for communications, navigation, and weather monitoring, also face serious threats from solar storms. Strong radiation and charged particles can interfere with or even damage satellite electronics, causing signal interruptions that affect phone calls, GPS positioning, and global information flow, throwing our daily lives into chaos. Lastly, I want to ask a wild question. If one day there's a super mega solar storm, would Earth completely shut down? Don't worry, no matter how intense a solar storm gets, it won't directly destroy life on Earth. Our planet has a solid atmosphere and a powerful magnetic field, two natural shields that continuously fend off the intense energy from the sun, preventing us from being harmed by deadly radiation. The atmosphere absorbs most of the harmful radiation, while the magnetic field acts like an invisible shield that directs charged particles toward the poles, creating beautiful auroras, but protecting most of Earth from impact. What we really need to be cautious about is the threat solar storms pose to human infrastructure. When high-speed charged particles hit Earth's magnetic field, they trigger geomagnetic storms that induce strong currents in power grids, potentially overloading or damaging transformers and causing widespread blackouts. Communication satellites can also be disturbed, leading to interruptions in GPS, phone signals, TV broadcasts, and impacting daily life and economic activity. Flight disruptions or rerouting and spacecraft system failures are risks that modern tech-dependent societies cannot ignore. As long as we have adequate scientific monitoring and protective measures, these issues can be managed and mitigated. Unlike earthquakes or typhoons, solar storms are predictable. Through satellite monitoring and ground observations, we can track solar activity in advance and issue timely warnings. Governments and relevant agencies can then adjust grid operations to protect critical equipment and minimize damage. Flight paths can be rerouted accordingly, and satellite systems can enter safe modes to reduce the impact of the storm as much as possible.
Phew, that's a relief. Otherwise, I was already about to start stockpiling canned food. After today's chat, I really feel like the sun is a giant that's both gentle and temperamental. On one hand, it gives us light and warmth, filling Earth with life. On the other hand, it suddenly throws a tantrum and scares us with a storm.
Exactly. That's the sun's dual nature. Understanding solar storms is not just a scientific journey. It's key to whether humanity can safely survive in space in the future.
Alright, if you also think solar storms are super fascinating, don't forget to like, subscribe, hit the notification bell, and leave us a comment telling us, what's the solar storm fact that surprised you the most?
Don't miss our next episode. We'll take you to explore even more amazing cosmic stories.